Excellent, excellent stuff. Okay, we're short of time. Let's crack on. He grew up in Somerset. He studied physics at Imperial College London. He's got a PhD in particle physics from Cambridge University and that's from CERN Geneva. In 1990, he joined the BBC Science Department. He's authored books, directed films, regularly speaks on science, cosmology, mathematics, information security, and check this out, he's an expert on the mathematical secrets of The Simpsons. He's fabulous. Please welcome Simon Singh.
Good evening, everybody. I'm going to tell you a little bit about this chap here. This is Pierre de Fermat. Very quickly, I'm going to start by telling you about Fermat and Fermat's last theorem. Okay, just stick with me for a second. A few hundred years ago, 350 years ago roughly, he was sat at home and he came up with this equation. X to the power m plus y to the power n equals z to the power n, where n's bigger than 2. And Fermat simply said that that equation has no solutions. Okay, now if you understand maths, you'll get that equation. If you don't get maths, don't worry. Essentially, that equation has no solutions. X to the n plus y to the n equals z to the n, n bigger than 2. To take a very specific example, x to the 12th plus y to the 12th equals z to the 12th, no solutions, okay? I'll tell you later why I'm giving you that particular example. And he was sure that this equation had no solutions. In fact, he was reading a book at the time, the Arithmetica by Diophantus, and in the margin of that book he wrote, "I have a truly marvellous proof of this fact. I have a demonstrationem mirabilim," he wrote in Latin. "I have a truly marvellous proof. But this margin is too narrow to contain it. Hac marginis exiguatis non caperit." So I can prove this, but I don't have enough space to write it down. And then he dropped dead. Or a few years later, he dropped dead. But people found this book, and they found this claim, and they found that Fermat said he could prove it, but nobody knew what Fermat's proof was. And so this chase began, this mathematical chase to rediscover Fermat's proof. And it's a great story because you have a mathematician here who kind of leaves us some buried treasure, a proof that nobody knows where it is. And everybody who wants to try and prove it fails. And the more they fail, the more they try, the more they try, the more they fail. Until a 10-year-old boy, a chap called Andrew Wiles, dreams of rediscovering this proof. And it takes him 30 years. It takes him decades. But eventually Andrew Wiles grows from a 10-year-old boy to a Princeton professor, and after working in secrecy for 7 years, is able to prove Fermat's last theorem. And it's a great story, and I've written a book about it, and I made a film about it, and I'm really proud. I'm really proud of this book because it's sold very well. It's been translated into 20 languages. But I know at the same time that not everybody reads maths books. Not everybody even reads popular maths books. This has a limited readership. And so when I get excited is when I see Fermat's last theorem popping up in pop culture. So, for example, there are plays. Arcadia by Tom Stoppard mentions Fermat's last theorem. There are novels. The Girl Who Played with Fire by Stieg Larsson has a cameo appearance by Fermat's last theorem. It pops up in a short story called The Devil and Simon Flagg, where the devil has to prove Fermat's last theorem in order to steal someone's soul. It crops up in a Hollywood film, Bedazzled, where Liz Hurley is a devil who tries to prove Fermat's last theorem. If you love TV, it pops up in Doctor Who with the 11th Doctor, pops up in Star Trek twice. And this is great for me because this is the thing I love, mathematics, appearing on the big screen. And the appearance that really pleased me the most is this one here. It even pops up in The Simpsons. In the second line from the bottom, this is an episode called The Wizard of Evergreen Terrace, where Homer wants to become an inventor, and he's working really, really hard. And just for a brief second, you see him in front of a blackboard, and if you're really sharp-eyed, you will spot that the second line is a reference to Fermat's last theorem. A number to the 12th power plus a number to the 12th power equals a number to the 12th power. Except that is exactly not what is supposed to happen, according to Pierre de Fermat. He said that equation has no solutions. But Homer gives us some solutions. And worse still, if you try and check that, if you have a phone calculator and you try and check it, it actually works. And so Homer seems to be defying Pierre de Fermat. So what's going on? Well, if we zoom into it, what it is, it's what's known as a near-miss solution. A near-miss solution means that if you actually calculate precisely on something with more digits on its display, 3987 to the power 12 plus 4365 to the power 12, it actually equals 4472.000.000.0071 squared, okay, up to the power 12, sorry. So it's a near-miss solution. It's good enough to fool your phone calculator, but it's not good enough to fool a real mathematician. So when I saw that, I was intrigued. There was clearly somebody on the Simpsons writing team who knew about Fermat's last theorem, and not only knew about Fermat's last theorem, but was mathematically adept enough to create this near-miss false solution. And I found out that the writer in question is a chap called David X. Cohen, who's a Simpsons writer, but before that he was a physics graduate from Harvard. After that he did a computer science degree at Berkeley, and after that he wrote mathematical papers. So he was really quite a serious mathematician at the Simpsons. And he's not alone, there's a guy called Al Jean, such a brilliant teenage mathematician that he went to Harvard to study mathematics when he was only 16 years old, 2 years ahead of the rest of the crowd. There's a chap called Ken Keeler, who has a PhD in applied mathematics. J. Stuart Burns was doing a PhD before he left to become a comedy writer on The Simpsons. Jeff Westbrook not only has a PhD, but he was a Yale professor before he left to become a comedy writer. So there are all of these mathematicians on The Simpsons. They love mathematics, but they're no longer mathematicians. And the way they express their love is by smuggling little equations like this into The Simpsons. And it's not just Fermat's last theorem, it's things like Pythagoras' theorem, pi, E, the irrational number, calculus jokes. There's a reference to Euler's equation, the most beautiful equation in the history of mathematics. There's references to ASCII. There is tons of mathematics in The Simpsons if you know what you're looking for. And I wrote a whole book about this. And I think the point of this is that what I found most exciting was that the writers of The Simpsons, okay, they do it for kicks. They love maths and they get a lot of fun out of doing this. But partly what they're doing is they're reaching out to the nerds out there. They're saying, if you're nerdy enough to spot these mathematical references, then you're as nerdy as we are. And we're kind of cool because we're Simpsons writers. And if you love mathematics the way we do, then you're kind of cool as well. And I think this kind of referencing of mathematics in pop culture is really important for just kind of making us nerds feel good about ourselves to a large extent. And The Simpsons is absolutely unique. There's one other example, another comedy series that has mathematics to the same extent that The Simpsons does. And it's Futurama. And that may not be such a surprise to you if you're a Futurama fan, because a lot of the writers on Futurama are also writers on The Simpsons. And so they also love mathematics, and they love getting mathematics into Futurama as well. And I'll just show you a couple of examples from Futurama. One of the things, for example, that you may have noticed if you're a really obsessive fan of Futurama is that the Nimbus spaceship has a whole registry number on the back. If you look very carefully, the number is 1729, okay? And you might think, fair enough, every spaceship's got to have a registry number. That one is 1729. Except Bender, the alcoholic robot, his unit number is 1729. He gets a Christmas card one year and it says, to Bender, unit number 1729. And in the Farnsworth paradox, where Fry is leaping in and out of universes, one of the universes he pops out of is universe 1729. So there's somebody at Futurama who thinks that there's something intriguing about the number 1729. And what is it about 1729? Well, it relates to this chap here. This is a mathematician called Ramanujan, arguably the most naturally gifted mathematician of the 20th century. He was born at the end of the 19th century into a very impoverished family in southern India. His 3 siblings died in infancy. He had smallpox, but he survived. He was given a fairly rudimentary education. They couldn't afford to send him to college, but it didn't really matter, because he would just go to the library and he would read mathematical textbooks, and he would absorb all the techniques and the tools and the theorems that were in these books. And then when he read all the books in the library, he started inventing his own theorems. And he developed about 120 theorems, groundbreaking theorems. And nobody around him understood what he was doing. He was light years ahead of everybody else. And so he put them into a giant package and he sent them all the way to Cambridge. And they landed on the desk of a professor called G.H. Hardy, Godfrey Hardy. And Hardy looked at this material and he couldn't believe it. These theorems were so beautiful, they were so fresh, they were so new, they were so innovative. And they'd come from somebody he'd never heard of on the other side of the planet. And he invited Ramanujan to come over to Cambridge. And Hardy, you know, most people won't have heard of G.H. Hardy, but he was no slouch. He was, in the early 1900s, British mathematics was in the doldrums. We were far behind the French and the Germans. And Hardy is credited with spearheading the mathematical resurgence in Britain. So he was a great, great mathematician. And yet he himself said, if I've ever done one truly great thing, it was to bring Ramanujan to England. Because once he was over here, his mind just flourished. He became one of the youngest members of the Royal Society. He became a fellow at Trinity College, the first Indian fellow at Trinity College. He was a genius, the genius everyone was dying to meet. But sadly, although his mind was flourishing, his body was suffering. The harsh Cambridge winters took their toll on him. He was a strict Hindu, so he was a strict vegetarian, and the Cambridge diet and lifestyle didn't agree with him. He became very seriously ill, and then he went back to India and died a year later at the age of just 33. So he died tragically young. But in his last few weeks in England, he was in a nursing hospital, a nursing home in Putney. And Hardy visited him. Hardy took a train from Cambridge, got to London, and then took a taxi cab all the way across London to Putney, got out of the taxi cab, went to see Ramanujan, and maybe not having much to talk about, Ramanujan said, oh, what was the number of your taxi? And Hardy said, oh, it wasn't very interesting, it was just 1729. Okay, 1729. And Ramanujan said, no, 1729 is a really interesting number. 1729 is the smallest number that's the sum of two cubes in two different ways. Now let me unpack that, let me explain what that means. Bear with me. 1729. It is 10 cubed plus 9 cubed. Now not many numbers are the sum of two cubes, so that's quite good. But it's also 12 cubed plus 1 cubed. And very, very few numbers are the sum of two cubes in two different ways, and 1729 is the smallest of all of those numbers. So it has this unique property. And it's called a taxicab number. So if you ever mention a taxicab number to a mathematician, they'll always know you're talking about 1729. And this story has kind of gone down in mathematical folklore because it's one of the last conversations we remember of Ramanujan. And it illustrates his great ability, that he had all these numbers at his fingertips, all these relationships. He was just able to pluck them out of thin air. He used to say that one of the Hindu goddesses would write mathematical truths on his tongue, and somehow they would get absorbed into his brain during his dreams. So he was an extraordinary mathematician. And what I love is the fact that Ken Keeler, who is the writer responsible for putting 1729 into Futurama, that's his way of 100 years later, acknowledging this man who was such a genius and who most people won't know. And it's just, you know, in an animated science fiction sitcom, you get this lovely little nod to the great Indian mathematician Ramanujan. And another example I'll just show you very quickly. There's an episode called The Honking. And that's when the Planet Express crew from Futurama go to a haunted castle. It's very spooky, it's very scary. And they're sat around waiting to hear about the reading of a will. And they're waiting there, it's very dark and scary, as I say. And then blood appears on the walls. And the blood that appears on the walls reads, not that figure there, it reads 0101100101, which is a binary number. And they look at it on the blood on the walls, and they take no notice of it. But then they see the blood reflected in the mirror. And when it's reflected in the mirror, you get a completely different binary sequence. You get 1010011010. And if you translate that binary number into decimal, you get the following. You get 2 and 8 is 10, 10 and 16 is 26, 26 and 128 is 156, 154, 154 and 512 is 666. The number of the beast. Okay? And all the Planet Express crew, Bender in particular, run out of the room screaming. They're terrified. because it's 666. But the astonishing thing is, that's never explained. The audience at home will never get that reference unless they can do binary to decimal translation on the fly. So that's what I love about this. That if you're a nerd, you will get that, and you will get a real thrill out of it, and that's what the writers want to happen. And so, it's been great fun writing this book, and one of the most fun things I did, I'll just finish with this quick story. I went to Los Angeles and I spent a week with the writers, and I interviewed them all about why they do this and what else they've got hidden away that I might not have noticed. And at the end of the week, and the last, I can't remember which writer it was. I think it was Al Jean. And I said to Al Jean, I said, look, Al, I've got all of these numbers. I've seen a narcissistic number here and so on. But what about 742? What is the significance of 742? And I know it's the house number in Evergreen Terrace where the Simpsons live. But why did you pick 742? It's not a perfect number. It's not a prime number. It's not a narcissistic number. It's not a Bell number. It's not an Armstrong number. It's not a taxi cab number. What's special about 742? And Al looked at me and said, oh, look, Simon, look, 742, what you've got to realise about 742 is it's just a number. And that was it. Thank you very much for listening. Thanks a lot.